For premium connections, most original equipment manufacturers recommend not only the parameters for assembly, but also that computer analysis equipment is used during assembly to monitor the full assembly process. These computers, in actual fact, receive data from the tong and the assembly and transpose it and translate it from a 3D mechanical process into a two-dimensional graphic display on the computer screen. Now the data coming across needs to then be interpreted, because you've got a 3D mechanical process being translated into a 2D depiction. So a specialist understanding the connection and the connection mechanics as it was designed must be there to interpret the actual graphic output. Because it's only a specialist that knows the connection will understand what the information on the two-dimensional computer screen is telling him. So it must be interpreted by someone that actually knows the connection, knows the design, knows the mechanics. Additionally, the actual equipment used, the load cells and the computers, etc., needs to be accurate. I mean, any computer is only giving you information that's as accurate as the information that's put in. So if the wrong information goes in, the wrong information comes out. So all equipment that's used in the makeup process, the tongs and the computers, etc., must be well maintained and accurately calibrated. Otherwise, you don't know what you're actually seeing being assembled is correct. So the graph depiction, essentially for a threaded and coupled shoulder design connection, will have 4 component parts, essentially speaking. The first will be a thread and seal build section, where the threads and the seal actually interact with one another during assembly, and actually are depicted as, in actual fact, a slope. Thereafter, there should be a clearly defined and indicated shoulder point, where the build slope finishes and the actual shoulder comes in contact during assembly. Thereafter, there should be a linear delta torque build to within set parameters, those set parameters by the connection designer and the connection manufacturer, which should have a minimum and a maximum as explained. And along with that, there should be minimal delta turns. So those 4 component parts, individually and collectively, need to be analysed by the specialist. He knows at any given time where along that graph the connection is and at what point of assembly it is. So the individual parts are analysed along with the whole graphic picture. Any individual part can be cause for rejection if there's something wrong with it and it doesn't fall within parameters, or the whole depiction can actually be cause for rejection of that particular makeup.